In the last class, we discussed the comparison operators, which was a good segue to introduce the where clause, which we said was the clause used to filter rows returned by our query. Most of the queries you will write will filter data in one form or the other. Therefore, you will be working with the where clause a lot. As a result, we will continue our discussion today where we stopped in the last class by discussing a term, predicates, which I briefly mentioned in the last class. Then we will shift our focus to the logical operators and, or, and not needed to help combine predicates when we have more than one. Finally, we will discuss handling those pesky nulls. But before I forget, along the way, we will be introduced to a new database object that we can also query apart from tables. It's a Park class, so let's get move on ASAP. We have discussed both arithmetic and comparison operators. We saw how we can write search criteria using the where clause in conjunction with comparison operators. However, all the search criteria we have written so far has been based on a single condition. For example, getting Canadian suppliers where country equals Canada, getting order shipped before a certain date where ship date is less than May 4th, 1998, etc. Look at the condition passed to the where clause, which we said is the filter clause of our select statement. In the first example, shift date is less than 1998 May 4th, or country is equal to Canada. This is what we call a predicate in set theory. A predicate is a logical expression that can evaluate to either true or false when the column examined does not accept nulls. When the column examined accepts nulls, then a predicate evaluates to true, false, or unknown. The way the where clause works is that it returns only rows for which the predicate evaluates to true and discard rows that evaluates to either false or unknown. Let's examine the more intuitive part, that is, when the column examined does not accept nulls. When we were asked to write a query that returned the product named Sasquatch Ale, we wrote the query. For this query, we supplied our filter clause, that is the where clause, with the predicate product name is equal to Sasquatch Ale. Because the product name column does not accept null, if you check the products table column definition in Object Explorer, you will see that the product name column is a Unicode character field of length 40 with not null nullability. The evaluation of the product name equals Sasquatch Ale predicate can only yield true or false. As I said earlier, the where clause only returns rows where the predicate evaluates to true. This means when the where clause examines each row in the product table, it looks at the product name column for that row and evaluates the predicate product name equals Sasquatch Ale. If the product name in that row is chai, then product name equals chai is not product name equals Sasquatch Ale. As such, it is false for our query and the chai row is discarded from the results. This process is repeated for each row until we get to the row that evaluates to true for product name equals Sasquatch Ale, which is then returned. If you are thinking to yourself that the predicate is nothing more than filter condition we talked about in the last class, you are correct. As we gain more experience, we will start referring to things with their proper technical names. Now that you know how the where clause works to filter rows returned, could we have a situation where we are interested in data based on a filter criteria made up of more than one predicate? Certainly we could. Imagine being asked to write a query that returned the data of all Northwind sales representative employees based in London. Here, our filter criteria needs to include not one, but two predicates. Employees must have the title of sales representative, while at the same time be based in the city, London. How would you go about writing these multiple conditions in your filter? This is where the next set of operators we will be discussing, the logical operators, shine. The first two logical operators I would like to introduce you to at this point help combine predicates when we have more than one. They are the and, or logical operators. Whenever you have more than a single predicate, you combine those conditions using the logical and or the logical or operator. The rules to use the logical and the logical or is quite simple, and it is beneficial to commit it to memory. If you need both predicates you are combining in the where clause to be true, use the logical and operator. However, if you need just one of the predicates you are combining in the where clause to be true, use the logical or operator. Let us revisit the query we were asked to write at the beginning of this section. Write a query that returned the data of all Northwind sales representative employees based in London. As stated above, we need to derive two predicates. The first being employees with title of sales representative, and the second, employees based in the city, London. The requirement of this query stipulates that both predicates must be true for all the data it would fetch. If we were expecting both predicates to be true, then to combine the two conditions, we will use the and logical operator in the where clause. Let's use the Query Designer version 2 to design this query. Pay attention to steps 5 and 6. In step 5, we want to know if we are filtering data or returning the entire rows in the employee table. In this case, we are filtering, which means we need our filter clause, which is the where clause. Because we answered yes in step 5, step 6 prompts us for our predicates. In this case, we have two that must be true, and our choice logical operator is therefore the logical and operator. We've therefore used the Query Designer to write a query that combines two conditions in its where clause. If you run the query generated, you see that 3 employees have the title of sales representative and are also located in the city, London. To visually verify this assertion, I have returned 5 columns that are needed for my verification from all the rows in the employees table. You should be able to write the query that produces the data you see here effortlessly. If not, please review our previous class. We see that even though 4 employees are currently located in the city, London, only 3 of them satisfy both predicates in our query, specifying that they have the title Sales Representative and City, London. Stephen Buchanan with employee ID 5 satisfies only one of the predicates, that is, his city is London, but he is not a sales representative. He is indeed a sales manager. What if the query requirement was write a query that returned the data of all Northwind employees that are either sales representative or based in London? In this situation, although we still have to write two predicates, the first, employees with title of sales representative, and the second, employee based in the city London, we really don't need both to be true. Either the title is sales representative or the city is London. Either one will suffice for our data needs. Based on the logical and/or rules we stated above, because either one of these two conditions suffices, we will use the OR logical operator to combine these two conditions. Let's design our query with the query designer. Notice how our query changes based on the logical comparison used in step 6. If you run the query we just derived, we will see that 7 employees are either sales representative or are in the city, London. This is different from the 3 employees we got when we used the logical AND operator. It is important to note that the accuracy of the data returned by your query depends on selecting the correct logical operator based on the query requirement when you have more than one predicate. Let's do a few logical arithmetic exercises together to solidify our understanding of the logical and logical OR operators. This should help you to figure out the final result of evaluating predicates with the logical and or. Looking at the above, you see you have 2 expressions in parentheses, one on the left and the other on the right, combined with the logical and operator. Assume you are evaluating the above expressions and they are 2 predicates, which means the only answer you can give is either true or false, nothing more, nothing less. Starting on the left side, if we evaluate the first expression, 2 is less than 5, we realize that this is a true statement. Next, let's evaluate the expression on the right. 3 is greater than 2. This is another true statement. Logically, the above expression now evaluates to true and true. Both sides evaluate to true. From our rules for the logical AND operator, where we said both sides must evaluate to true whenever you have the logical AND, the entire statement we started with evaluates to true because both our component expressions evaluates to true. How about another one? This time we have, well, the first expression still evaluates to true, but the second expression evaluates to false because although 3 is greater than 2, but it is not equal to 2. Logically, our statement above now evaluates to true and false. We have a situation here where one expression is true, the other is false, but they are combined with the logical AND operator. What happens in this situation? It's simple. The rule says in order to be true, both sides have to be true. Since this is not the case here, the entire statement evaluates to false. Try your hands on this last one. What does the statement below evaluate to logically? Pause the video here to be able to evaluate. If you said false, you are correct. This brings us to the concept of the truth table. Whenever you are using either the logical AND or the logical OR operator to combine predicates, the final result of your evaluation is shown in that logical operator's truth table. Let's explore the truth table for the logical AND first. Remember, the logical AND combines 2 Boolean expressions and returns true when both expressions are true. The truth table has vertical column headers with a green background and in blue font named true, false, unknown. It also has an horizontal row header which are also in the green background and blue fonts. The result of evaluating two expressions, one on the column header and the other in the row header, is shown in the intersection of both headers in black font. So, if the first predicate evaluates to true on the vertical header and the second predicate evaluates to true on the row header, the result will be true, which is the intersection of the vertical and row header. If the first predicate evaluates to false on the vertical header and the second predicate evaluates to true on the row header, then we see based on the intersection of both that the result is false. Because we have been dealing with evaluation that results in either true or false, you can ignore the unknown headers for now. We will come back to that later. But feel free to combine unknowns with either true or false to see the results that it yields. You see all the possible combination of the logical AND. When you combine two true expressions, your evaluation yields true, as you saw in the first expression we evaluated above. Combining a true expression with a false expression yields false, and combining a true expression with an expression that evaluates to unknown yields unknown. A careful study of the logical AND truth table reveals the following. Only when both expressions evaluate to true would you get a result of true when the expressions are combined with the logical AND. Any combination with an expression that evaluates to false yields false when you combine both expressions with the logical AND. When you combine an expression resulting in false with another expression with an unknown result, it yields false. The logical OR operator combines two Boolean expressions and returns true when either expression is true. Let's revisit our logical arithmetic where we evaluate two expressions, but this time using the OR logical operator. I am sure you know where this is going. We are going to derive a logical OR truth table, but let's not get ahead of ourselves. Evaluating the above, we get on the left side true and on the right side true. Now we have true and true combined with the OR logical operator. Both sides evaluate to true, and all we need is for one to yield true when we use the OR operator. The above statement evaluates to true. For the next set, here our initial evaluation of both sides results in true for the left side, false on the right side. Combining them, you have true or false. The final result is true for this expression because all we need when we use the logical OR is for one of the expression to evaluate to true. Now let us review the logical OR truth table and then you will try your hands on a final expression. Read the logical OR truth table the same way you did the logical AND truth table. Vertical headers, horizontal headers, and intersection of both. Can you work out what the expression you have on your screen evaluates to using the logical OR truth table? Don't say it out loud yet. Give everyone about 5 seconds to also get their answers. Let's wait. If your final evaluation is false, you are correct. Left expression evaluates to false because 5 is not less than 2. Right expression also evaluates to false because 2 is not less than 1. You now have two false combined by a logical OR operator. If we look at the logical OR truth table, at the intersection of a false vertical header and a false row header is a false data cell, which is our final evaluation. This means that whenever you are writing queries where you need to combine predicates in your where clause, you can pull up either the logical AND or the OR truth table to determine the final result of your evaluation. Also note that the order of precedence is that the AND logical operator is evaluated first before the OR logical operator if both are in a filter condition. Armed with this knowledge of the logical and OR operator, let us look at another database object that we can query. This object is called a view. A view is a virtual table because it is the result of a select statement persisted in databases. We will have a lot to say about views later, but for our practice with logical operators, consider a view as a table. It has a name, columns, and can be queried just as a table. You can access views in the Views node in any database object explorer. If you expand the views node of the NotWin database, you will be able to see all the views currently in the database. These are the ones we will query shortly. From the alphabetical list of products view, write a query that shows all condiments selling above or at $10. Take a quick minute to design your query before writing down the code. Also note you are free to use the query designer for your design. As with any query you are going to write, you need to take time to browse the data to know where things are located. A quick browse of the alphabetical list of products view shows us that condiments are located in the category name column and prices are in the unit price column. Our query requires two conditions: category name of condiments and 2, unit price greater than or equal to 10. Because we have two required conditions, what logical operator will we use to combine them? The answer lies in the query requirement. Both conditions must be true for our query to be valid. Hence, we know that our logical operator for this query must be the logical AND. With all this in mind, let's fire up the query designer. As usual, pay attention to steps 5 and 6. And just like that, we have our query. Be careful, the view name has white spaces in it. So as we learned earlier, we need to use square brackets to delimit the name. Run the query you just derived to see all the condiments currently selling at or above $10. Try your hands on these questions displayed. At the beginning of this class, we defined predicates as logical expressions that evaluate either true or false, but there is a caveat. This is when the column involved does not allow nulls. That is, the column is not null. We have been discussing this happy path until now. Let's turn our attention to those pesky nulls and see how they affect our filter query. When a column allows nulls, then a predicate can evaluate to true, false, or unknown. The where clause will still return only rows evaluating in true, thereby discarding false or unknown rows. We will use the NotWin's employees table to see how we need to be careful when querying data with columns that allows null. The region column of the employees table allows null. which makes sense because countries like UK do not have regions. Hence, a null signifying that the region value is unknown for that row is recorded. If you write a query to return employee data in the region WA, that is Washington, you will come up with a query like this. Run the query and you get back all the employees in the region Washington because your query instructs the where clause to do just that. All is well and good in query land. What if you now want to see employees that are not in WA? That's simple enough. You just change the comparison operator to a not equal operator in your predicate. When you run this new query, you get 0 rows back. However, you know there are employees in the table that are clearly not in the region WA. What's happening here? If you look at your predicate, region is not equal to WA should return true when region equals null. But as we said in the last class, you cannot compare nulls with anything. And if you pulled up the logical and truth table, you will see that combining true, the region expression, with unknown, null, yields unknown. Therefore, when region is compared with the null region row, while your filter is evaluated, it yields unknown. And because the where clause discards false and unknown predicates, these rows are discarded by the query, and you do not get any rows back. Do you remember what we said was the comparison operators when nulls are involved? We discussed this in our last class. It is the is null operator. We will use the is null operator to solve this null problem. From the updated query, you see we added another predicate solely for nulls, and we combined both predicates with a logical OR because we want either the region to not equal WA, Washington, or the region be null. If you run this new query, you will see all our employees clearly not in Washington. When writing queries, pay special attention to columns that allow nulls and make sure you are handling nulls appropriately. Try this exercise. Write a query that shows all the orders where their ship date is not known because the ship region is unknown. There is another logical operator you should know about. It is the not operator. All it does is to negate a Boolean expression. When an expression is true, adding the not operator makes it false. That is, not true is equal to false, and vice versa. Human beings use this not operator more often than you realize. So it's not just a programming thing. When someone asks you how you are doing, you tend to go, not bad, and they intuitively know you are good. You just use the not operator to negate bad, thereby flipping it to good. By the way, you can negate the is null operator we just learned about as well when dealing with nulls. It becomes is not null, which means there is a value present. Let's look at the logical not truth table. It's pretty straightforward. With this in mind, look at a query we wrote earlier to get all the sales rep in London. However, this time we want to use the not logical operator to derive a query that gives us sales rep that are not in London. Notice how we use the not logical operator here. This query will return all sales rep that are not in London from our employees table. Execute the query in SSMS and pay attention to the city column in the result set to verify you are truly returning the correct result. Still using the same query and the not logical operator, can you write a query that returns data for employees that are neither sales representative nor located in London? Once you write your query, run it and review the result. In my opinion, the not operator is a quirky way of writing this particular query because you could have just easily written it with the not equal comparison operator. Change your not query to one with the not equal comparison operator and see if you still get the same number of rows. Yes? No? I would like to hear your response. We have covered quite a lot in this class, and you are on your way to becoming seasoned SQL programmers. You deserve a break now. When we return, we will continue to expand on how we can filter data using more operators. See you in the next class.